So in this lecture, we are going to discuss about what is a balance section, under reinforced section, and over reinforced sections. Under which condition the section becomes under reinforced, over reinforced, or balanced one. So we have three types of section in RC section. These are balanced section, under reinforced section, and over reinforced section. So as the name suggests that balance section means there is the balance or at the same time complete and still reach their permissible value, whereas under reinforced means reinforcement is less, while over reinforced means the section which has relatively high amount of reinforcement than balanced section. So the concrete reinforcement is more, that means concrete strength of concrete is less, and that results in a better failure of that element. So we'll go one by one. Balance section, just look at the definition. A balance section is that in which stress in concrete and steel reach their permissible value at the same time. So moment of resistance capacity of a section calculated by steel or by concrete will be same. That means, for example, this is the section of RC beam or column or anything else, it doesn't matter. So but in this case just we are looking for a RC beam section. So this is the section of beam. For example, this is the case, this is a simply supported case, and here is the load on the beam, and the section of this one is like this. Okay, we can calculate the value of induced moment shear force by using analysis, and we have also derived formula, but we are not going to calculate this all these things in this session. We will do later if we need to do that. But just we are just assuming the reinforcement here. For example, we have 3 reinforcement at bottom here, and the size of reinforced beam is B and D, and this reinforcement of total amount of steel reinforcement is AST. Okay, as there is only tension at the middle section, and we do not need to provide top reinforcement, but just to put steros, we need to provide top reinforcement at least 2 on left end and right side, right end. So only then we can provide steros like this one. So we are just, these are just 2 reinforcement as hanger. So we can calculate whether this section is balanced, under reinforced, or over reinforced. In IS 456 2000, there are derived equation from where we can calculate the neutral axis, and after finding out the neutral axis where it lies, then comparing with the maximum limitation for neutral axis, we can find out whether the section is balanced, under reinforced, or over reinforced. Okay, so look at here. I think in the theory we do not need to write all these things, just we have to write about what this means, and is it better to use in the real field. So these are important things. So we will not calculate all these things, just we focus on the theory only for now. So we know that this is the section, and this is, for example, this is the neutral axis, and we have 3 reinforcement at the bottom, and when the load applies on here, we know that it bends, and this bottom steel will be activated. So in balance section, as the definition says that concrete and steel reach their permissible limit, which means this is the neutral axis and the upper part will be in compression, and the below portion from neutral axis will be in tension. So we know that every material has its own permissible value, and for this, upper part is concrete and lower part is reinforcement steel. Okay. So in this section, when the load applies in here, and it will be fail when, or it will reach its permissible level at the same time. That means this is the beam longitudinal section like this, and this is the load. If we increase the load here, and at a certain time the beam will fail. At that time, the concrete at upper side and still at the bottom portion will reach its permissible value simultaneously. Okay, this is the most economic section, most optimized section, because its concrete and its reinforcement reach their permissible value at the same time. So this is the balance section. Balance section. Okay. So another one is under reinforced section. Under reinforced means under means low and reinforced means still. Okay. That means reinforcement is provided below than the then it is required for a balance section. So look at the definition here after here, and I will describe what does this mean. Okay, so in under reinforced section, the stress in steel reaches its permissible value because the steel provided it on the tension side there is less than the balance section, so it will first undergo its permissible value than concrete. Okay, so in under reinforced section, the stress in steel first reaches its permissible value while the concrete is under stressed. Okay, so in an under reinforced section, the percentage of steel provided is less than that provided in the balance section. So how can we calculate the moment of resistance of this type of section? So as it says that the steel reaches its permissible value at first, that means we have to calculate this moment capacity of the section by steel reinforcement. So before that, the various features of under reinforced sections are as follows. They are: steel is fully stressed while concrete is not. The actual neutral axis lies above the critical neutral axis. The percentage of steel is less than the balance section, and section is economical. But at the same time, we should keep in mind that the section is yielding here because we have provided less reinforcement. The steel will undergo yielding. That means failure at first, and it is ductile failure because we know that steel can yield even though it undergoes it reaches its yield stress, because it can undergo steel hardening and it can raise up to ultimate stress before fully collapse. So it offer ductile failure. So just look at here the diagram. Okay, so here, for example, for a balance section, we need to provide 320 bar, but in under reinforced section, we can assume that the bottom 3 bar may be 316 bar. Okay, so so the reinforcement in the section is less than the balance section. Okay, in this case, the neutral axis, the actual neutral axis lies above the critical neutral axis. So, for example, we have limited neutral axis is here, that is actual max. But in the case of under reinforced section, the actual neutral axis is above the neutral axis like this. Okay. So that means we have this part. This is away far away from actual neutral axis. So under reinforced section has less percentage of steel than that for balance section. So it has offer ductile failure. So the last one, we have over reinforced section. What does that mean? That means over reinforced section means if a section has more amount of reinforcement than it is provided for balance section. That means if in that example the provided reinforcement might be 325, whereas under reinforcement we have provided 316, and for balance section it is 325. This is for balance section, this is for over reinforced, might be, but we haven't calculated the detail. But just we are assuming this is just we want to focus on this concept. So we haven't calculated full calculation, full detail or full calculation. Just we are going to understand this concept through just a simple example. Okay, so this is under the first one, under reinforced. Okay, so here let us read of course this theory, this definition. In this section, stress in concrete reaches its permissible value, while still is not fully stressed. This is because we have provided over reinforced. Then that means we have provided more reinforcement than it is required to be a balance section. So the steel is more, that means steel wouldn't go to fully stressed. At the same time, the concrete might go to might reach its permissible value. So steel is not fully utilized. The over reinforced section is uneconomical. In an over reinforced section, the percentage of steel provided is greater than balance section. concrete is fully stressed while steel is not. As I said earlier, concrete is fully stressed, whereas steel is not, because still we have a very steel in more amount than it is required for band section. The actual neutral axis is below the critical neutral axis, just opposite to that of under reinforced section, where the actual neutral axis lies above the critical neutral axis. But in the case of over reinforced section, actual neutral axis is just below the critical neutral axis. The percentage of steel is more than band section, so the section is uneconomical, because in this case the reinforcement provided at the tension side is more than that is required for band section, so which is uneconomical. And among them, the one of the major limitation of this type of section is sudden failure, because as you know that concrete cannot hold large amount of tension force, as it has a low tension capacity, and while we add more amount of load on the beam, then there will be sudden failure, in contrast to just unreinforced section, which is neutral failure. So sudden failure, that is brittle failure. Okay. So just comparing these type of section, balanced section and under-reinforced section, and the last one is over-reinforced section. We know that balanced section is more economical section than other sections, because for that particular load, if we engage in it, and the section is more economical if it reaches at the same time concrete in compression fully stressed, whereas steel is fully stressed in tension. But we know what balanced section is also sudden failure, because at that time concrete is also reaches its permissible limit. So most of the designers choose to under-reinforced section, because during experiencing earthquake or any adverse condition, the customer or the people know that the beam is going to fail, so they are going to be aware of the possible consequences of failure of that beam, so they can easily escape out from the building or from the structure. So it is better to provide under reinforced section than other two types of section. In this way, we can categorize the section which is under reinforced, over reinforced, and balanced section.